beneath the glittering surface of our reality. In the microscopic shadows and scars of our planet's most unforgiving corners lies a creature that shouldn't be possible. We have sent rovers to Mars and mapped distant galaxies, yet we are only just beginning to understand the vertical universe of microscopic life that has existed since the dawn of deep time. This is the world of the tardigrade, an animal that is not just a biological oddity but a design that broke the rules of everything we think we know about survival. While we often look to the last emperors, like the T-Rex or the 50-foot titanoboa, to define the limits of life, the true masterpiece of biological engineering is barely half a millimeter long. It is a creature shaped not by size, but by an ancient bargain with evolution that allows it to outlast the very fires of extinction. To understand the tardigrade, you have to understand the sheer violence of Earth's history. A few hours after an asteroid strikes, the skies turn into burning clouds of metal and ash, and the air fills with falling stones still glowing from space. In this nuclear winter where photosynthesis stops and the food chain becomes a few scattered links lying in the dirt, almost every large organism vanishes. But in the darkness, life does not vanish completely. It bends it, hides it, waits. The tardigrade is the ultimate survivor of the extinction. A creature that likely watched as oceans lifted into walls of vapor and forests flattened across 5 different mass extinctions. They are evolutionary prototypes that have persisted through a bottleneck of starvation and cold that erased dynasties of dinosaurs and titans, while the T-Rex was a late arrival that lived only during the final stretch of the Cretaceous. The lineage of these microscopic, 8-legged architects stretches back over 500 million years to a time when life was still figuring out how to survive on land. And here's the thing: nothing about the tardigrade's biological blueprint is normal. In a world where we define survival through activity and consumption, the tardigrade has mastered the art of the near-shutdown. When the environment becomes lethal, when the water vanishes, when the temperature soars past 1,000 degrees, or the pressure becomes a chamber that would crush human bones into splinters, the tardigrade doesn't die. Instead, it enters a state called cryptobiosis, or the ton state. Its metabolism, much like a sperm whale diving into the abyss, drops to nearly zero. Its body collapses its own structures and expels almost all of its water, turning into a dry, lifeless husk. In this state, it is no longer an animal in the traditional sense. It is a time capsule of biological information waiting for the world to become hospitable again. It is a masterpiece of biological engineering that allows it to survive absolute zero and the crushing force of the Hadal zone, where pressure can exceed 1,000 times what we experience at the surface. But here's what surprised me in the vertical universe of the deep. We see creatures that grow to impossible sizes, like the giant isopod or the colossal squid, as a response to the desert of nutrients. The tardigrade takes the opposite approach. By remaining microscopic, it finds corners to cling to that larger animals cannot even perceive. Its 8 legs, though they lack the extensor muscles and hydraulic systems of the spider, move with a slow, deliberate gait that seems almost comical until you realize they are designed to navigate the film of water on a single piece of moss. Like the octopus, which possesses genuine autonomy in its limbs, the tardigrade's movement is a tactical operation perfectly adapted for its ecological niche. It possesses simple fangs and a fundamentally different approach to sensing the world, relying on chemical receptors to taste its environment, much like the suckers on an octopus arm. The tardigrade is a biological thermometer for the extremes of our planet. It thrives in the freezing abyss of the Antarctic ice shelf, where exposed skin freezes in under 2 minutes, and near the hydrothermal vents of the ocean floor, where superheated water spews toxic chemicals. In these scars of the Earth, where life is based on chemistry, not photosynthesis, the tardigrade is an opportunist that doesn't wait for perfect conditions. Like the fun spike that signals a world trying again after a total collapse, the tardigrade is the first to reclaim a scorched landscape. It is a ghost against the blue of the microscopic world, practically invisible to the predators that stalk the twilight zone of the soil and water. And yet, there's something deeper here, something that breaks every assumption we have about what makes a successful organism. Scientists have found tardigrades in samples taken from the highest mountains on Earth, living in ice at elevations where the air is so thin that humans lose consciousness within minutes. They've been discovered in the deepest ocean trenches in pressures that would implode a submarine in seconds. They've survived being heated to 151 degrees Celsius and frozen to -272 degrees Celsius, just 1 degree above absolute zero. the temperature where atoms themselves nearly stop moving. They can withstand radiation levels 1,000 times higher than would kill a human being exposed to that shred DNA into fragments, and somehow they repair it all back together, as if nothing happened. In 2007, scientists sent tardigrades into space, exposed them to the vacuum and to unfiltered solar radiation, the kind that would cook human tissue in moments, and when they brought them back to Earth and rehydrated them, the tardigrades simply woke up. They didn't just survive, they reproduced afterward, producing healthy offspring, as if their journey to the void had been nothing more than a brief inconvenience. This isn't adaptation, this is something else entirely. This is a form of life that operates by rules we're only beginning to decode. Here's the thing about the tardigrade survival mechanism. It's not just one trick, it's a symphony of biological engineering working in concert. When it enters the ton state, its cells produce a sugar called trehalose that essentially replaces the water in its tissues, forming a glass-like matrix that protects cellular structures from damage. It's the same strategy that allows certain seeds to remain viable for decades or centuries in dry storage, but the tardigrade has refined it to an extreme. At the same time, its DNA gets wrapped in protective proteins that shield it from radiation and prevent breaks in the genetic code. If damage does occur, specialized enzymes go to work repairing it with an efficiency that makes our own cellular repair mechanisms look primitive. But there's another layer to this biological blueprint that we're only now beginning to understand. Recent research has revealed that tardigrades possess unique proteins found nowhere else in the animal kingdom, proteins that can sense when the environment is becoming hostile and trigger the transformation into the ton state before it's too late. These proteins act as early warning systems, giving the tardigrade time to prepare to shut down, to transform itself from a living, breathing organism into something closer to a spore or a seed. This is not passive survival. This is active engineering a creature that has evolved to see danger coming and respond by becoming nearly indestructible. And this brings us to the deeper question, the one that keeps scientists awake at night. How did this evolve? In the deep sea, gigantism makes sense, because food is scarce, and a slow metabolism paired with a large body allows you to wait out the long periods between meals. In the abyss, bioluminescence makes sense, because it's the only way to see or be seen in the endless dark. But the tardigrade's extremophile abilities seem almost over. Why would a creature living in a film of water on Mars need to survive the vacuum of space or temperatures that exist nowhere on Earth's surface naturally? The answer lies in deep time and in the sheer randomness of extinction events. Over 500 million years, Earth has been hit by asteroids that turned the sky into flame and the atmosphere into poison. It has been gripped by ice ages that locked entire continents under glaciers kilometers thick. It has been scorched by volcanic eruptions so massive they released enough gas to change the chemistry of the oceans and the air. The tardigrade's ancestors didn't evolve to survive space. They evolved to survive everything Earth could throw at them. And by preparing for every possible catastrophe, they accidentally became prepared for conditions that don't even exist here. This is where evolution becomes strange, because evolution doesn't plan ahead, it doesn't build for scenarios that haven't happened yet. But in a world as violent and unpredictable as Earth, the organisms that survive are the ones that were accidentally overprepared. The tardigrade is living proof that sometimes the most extreme adaptations, the ones that seem like overkill, are the ones that allow a lineage to persist when everything else dies. We often think of intelligence like that of the clans of sperm whales, with their sophisticated dialects, as the peak of evolution. But the tardigrade forces us to question that limited framework. Intelligence is a sophisticated solution to environmental problems, but so is industry. The tardigrade's cognitive architecture isn't built for symbolic thought or social cooperation, but for endurance and patience. It is a mind, if we can call it that has outlasted the dark for 500 million years without the need for a brain 6 times larger than ours. It is an experimental design that proved that to inherit the Earth you don't need to be the last emperor of a fallen world, you just need to be the one who can survive the end of it. This has profound implications for how we think about life beyond our own planet. For decades, the search for extraterrestrial intelligence has focused on radio signals and large-scale engineering. But if life can adapt to such extremes here on Earth, what might alien intelligence actually look like? Perhaps The universe is not filled with civilizations, but with survivors' minds more similar to the distributed sensation of an octopus or the dormant resilience of a tardigrade. If a microscopic animal can survive the vacuum of space, it suggests that the boundary between self and environment is far more permeable than we imagined. Life is not a fragile chapter, but a stubborn green that finds a way to bend, hide, and wade across the unimaginably deep past. When a child stands before a skeleton of a T-Rex, they feel a connection to an animal that died 66 million years ago. But when we look through a microscope at a tardigrade, we are looking at something even more extraordinary. We are looking at a living fossil that has remained largely unchanged for millions of years because its world has never demanded it to evolve further. It is a refuge for the very idea of life. A creature that rewrote the rules of what's biologically possible long before humans ever drew monsters in the fog. As we stand in the twilight zone of our own ecological history, watching as wetlands are drained and ecosystems collapse due to our own actions, the tardigrade remains. It doesn't flee or attack, it simply exists. It is an engineer of survival, a navigator of the microscopic void. While we worry about planet-level consequences and climate cycles, the tardigrade has already seen it all. It is a signature of a world trying again, a fragile, gelatinous, yet resilient proof that life is too much to be erased. In the end, nothing about the tardigrade is normal, because normal is an assumption based on our own limited history. Evolution doesn't operate according to rules. We can easily articulate it operates through constraint, variation, and selection across deep time. The tardigrade is a reminder that we are merely guests in a world that has seen many dynasties rise and fall. It is a mind reaching out to meet ours from the primeval swamps of history, telling us that discovery is not rare but constant. To study the tardigrade is to glimpse the possibilities of life itself, a resilience that reinvents itself to endure the most extreme pressures imaginable. It is a story that belongs to all of us, a chapter in the book of Earth that will continue to be written long after the last city in the dark has vanished. The tardigrade doesn't just survive the ocean or the land, it helps build it one microscopic step at a time across the endless night of eternity.